Okay. Hello, everybody. I'm prepping for Advent of Code. I'm very excited to see what kind of shit I can churn out in the allotted time today. I've got a nice bit of time. Day 13. Day 13. Okay, here we go. Here we go. It'd be really funny to get this camera up here for some reason as well, but it's just not necessary in this arrangement. Man, in the future, what I should do is when I'm doing these streams, I should like write a little bit of my story, just like in the 5 minutes before. Uh, yeah, just so I can have a little bit more, and I can then publicize it in this kind of way. I get sub 630. I'll quickly check on. See what Matt Tyro's up to. On pace for sub 7. So to be it. 2 plus 47 plus 41 times the divided by 60. 47 plus 6 times 60 is 60. Yeah, he's gonna get sub 6. I believe in him. That's pretty funny. Okay. We're prepping for happening code. So, I'm feeling pretty good about today. I don't know why, but I kind of have an optimistic feeling. Today, I feel like really in the zone. I'm so ready to get owned by day 13. Dude, I don't know why, but like the second Thursday and second Friday tend to always be really, really fucking brutal. So I'm expecting today to be like, oh, just do 20 quadrillion iterations. Should be pretty easy, right? And the whole question is going to be about abstracting away from exactly that. Okay, here we go. Oh no! Next up, lobby of a tropical island. The historian take a moment to admire the technical forward for starting out. We're going to do arcade. Maybe you can win some prizes from the claw machines. A little unusual. Instead of a joystick or a directional button to control the claw, the machines have two buttons labeled A and B. You can put in a token and play. It costs 3 tokens to push the A button and 1 token to push the B button. With experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right on the x-axis and a specific amount forward. Each time the button is pressed, the machine contains 1 prize. To win the prize, claws must be positioned exactly above the prize on both the x and y axes. What is the smallest number of tokens you would have to spend to win as many prizes as possible? So every machine's button behavior and prize location. The list describes the button configuration and prize location of 4 different claw machines. Just consider the first claw machine in the list. Move the claw 90. So the B button, move the claw this. Yep. Oh man. Okay. You estimate that a button would no. You estimate that each button would need to be pressed no more than 100 times to win a prize. How else would someone be expected to play? Figure out how as many prizes as possible. What's the fewest tokens you would have to spend in order to win all possible prizes? Okay, so what's the low number? 1278. Hmm. There we go. Okay. So we have. Huh. Nope. Okay. Nope. Never mind. We're not going to do that. If I just do result 0. Okay. Cool. So it does actually work. So, um, um, so I got some weird goofy shit here. If um, the result I 2, result I 3. Okay. Um, there we go. Oh, it's the closing this that I need. Oh. What I need to do. Whoop, not bad. This is going to be an integer every single time, but I still have to put it in manually. I get that. Cool. Sweet. Okay, so this works. And now, if I just do buttons 0, 1. Fuck, other way around. There we go. Can I do this and then... Was like being a werewolf. Did it fucking break again? No, it should work. I'm just not naked today, so I can do this. Oh, sorry, it's this one. So I've got to do 2 to 4. Is that right? There we go. That's what it is. 2 to 4. And this is 2 to 6. There we go. Okay, and I think these are all 4-digit numbers. I'm assuming... no, actually, it should just be... it's not 2 to 6. That's annoying. To length result. Will that work? Okay. In fact, I'm going to do that on all of these. Sweet. Okay. And that seems like it works. Awesome. Let's turn these into integers. Now this should just work. Like that. That's correct. Okay, cool. So let's do just buttons 0. Sweet. Okay. 1632, 5311, 6788, 4716. Awesome. Okay. So, um, so I'm gonna do is I'm going to do looking at A, we're going to see how many presses it takes to get to one or the other. So, for in range len buttons, AX equals buttons I 0, 1, 0. AY equals buttons I 0, 1. BX equals, let's pretend that's 1. BY equals 1, 1. Prize equals, let's call this PX is equal to 2, 0. PY is equal to 2, 1. There we go. So, we need to start by finding how many A button presses you, well, so we start by seeing which one you need fewer button presses of to reach one of the values. So, AX to PX is equal to PX divided by AX. AY to PY we do the exact same things with BX and BY. Ah, nope. So this is always BX. So we want to do whichever one is the lowest. Okay, so that's the minimum number of presses we need in order for us to start breaking over one of the values. From then, we're going to start replacing button presses with the other one. So while we're going to start with total presses equals min press. No, actually, we're going to do x press equals 0, y press equals 0. So while x press is above 0 and y press is above 0 and ax times x press plus a y times, no, it's bx plus x press does not equal tx. And the same thing the other way around. We'll replace y, 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 y. Wait, no, it's not x press, y press, it's a press and b press. So this is the only way we can make sure that doesn't work. So this means you need fewer a presses to get over the hump. Now we do, oh, there's equals a press equals min press, or b press equals min press. Okay, there's equals a. Then we do a press minus equals 1. So in here, we're going to do while so now we're going to add B presses until we get back over our target threshold. While AX times A press. Okay, so now we've finally gotten over the threshold. So we just do the exact same thing in reverse. Oh, fewest tokens. You want to do if this is true, where they are perfectly equal, then this is just going to be empty. Then we're going to do valid list dot append a press b press. Is it 2 for an X? Okay, 3 tokens for an A. Valid list 0 plus. $58. It should be like this. Let's say that's 62. Yeah. Um. It truncates decimal part. Yep. Now it's thinking. Oh, shit. The print Total sum. Fuck. This should work. Let's take a second, but it should work. Are there any minuses? I didn't even consider that. There aren't. Okay. Is there a loop that's breaking somewhere? So why is this not working? Oh. B. Der. List indices must be integers or slices, not a list. Oh, for J in range len valid list. Yep, how to do it. 69, list index out of range. Yep. Bam. 29517 does not seem correct, but we're going to try it anyways. It's the right answer. Oh, okay. It's got the clause nowhere near what you expect it to be due to unit conversion error in your measurements. Position of every price is actually... Holy shit. 2, 3, 4. So that's million, billion, trillion. So it's 10 trillion higher on both the X and Y axis. Add 10 trillion to the X and Y position of every prize. After making this change, the example would now look like this. Okay. So this is a question of differences, right? You need to be able to end up with a difference that's a decent amount, right? You need to be able to control the difference. So this is a plus 16 difference. This is a minus something difference. And the goal is to do it arbitrarily and reach an arbitrarily large size. If I always start with A, no, I always start with B. So you want the fewest number of A's possible. We always start with B in this case. We just get rid of this. I don't even shit that I'm cannibalizing my part 1. So we're just going to do B press. Starts with that. A press equals 0. We're getting rid of Durstart entirely. We're getting rid of this entirely. Because B is cheaper, we're doing it this way. Because the moment it lines up, that's the correct answer. Okay. Now, okay. So if it's not equal, then B press minus 1. And then here we do else. File is not append, A press, B press, break. And it breaks out from the... Well, the worst case scenario would be 10,000, right? Let's start with 10,000 and hope we don't need any more than 10,000 iterations to find the difference per one. Is greater than 1. Then best total equals 3 times valid list 0, 0. Valid list 0, 0. Maybe if I just do valid list equals that. So I can just do this. And I can just add total sum to here. 44. Oh, I forgot a colon. 44 invalid syntax. $49 unmatched parenthesis. There we go. Gonna take a while, but zero. Okay. Oh. I need to have best total or total sum. I just do plus equals this value, can't I? I don't even need whatever the fuck best total is. Zero. Actually, we're gonna need way more because the worst case scenario is 100 to 1, and then 1 and 2. 2 and 1. Oh, I need to do a man. I need to figure this out. Okay, so if I have so it's min of bx by multiplied by b press. So this is the difference we need to make up. Actually, it'd be easier if I just did. Let's just do bx minus b press minus by times b press. So this is b diff. So, and we have, okay, this is bp diff. It's b to p diff. There we go. This is going to be b diff equals bx minus by. A diff equals ax minus ay. So We need to find some combination of B diffs down and A diffs up that get us to the right answer. Well, instead of +1, it would be plus the current number minus px. Because right now we are assuming that px is larger. So it should be px minus these numbers. Divided by look up to the right amount. Let's do the max of this. And then the same thing, but with y. That should actually work. Because it'll work, because if these are the exact same away, then it'll just be the exact same number. Otherwise, it'll be the biggest possible number to close the gap as much as possible. Oh. Oh. This should get pretty fucking close. Oh my gosh, okay. So we need to look about the differences, right? So we have a B diff and a Y and an A diff. We need to somehow apply B diffs and A diffs. What if I do dual diff? Let's do D diff equals well, if we swap out a B for an A, that's not what we want to do. Huh. I had a bit of difficulty thinking. So we know how many B presses it would take to get all the way up to the number. Cool. Now what we want to do is we want to strategically take away chunks and then add A's. Shit, it might actually not be a bunch of B presses. Because it's possible that if an A is triple the value of B, if all of the buttons are triple the value of B, then it will not be the case that B is preferred over A as the primary button to press. Because only have a ratio of 3 to 1. Oh, geez, that's tough. Is the correct way to do it to have both an A path calculated and a B path calculated? Okay, so yeah, we need to figure out. So, like, if you do all the A's and it says you need to get another 100 here. Well, the way that you get 100, adding a B, yeah, because it's about the difference between the two, right? If you add an A and a B, no, that's fucking Jesus Christ. This is fucking difficult, dude. Because it's a modular arithmetic problem, but it's a really fucking weird modular arithmetic problem. So does is it always possible? It's not, is it? To press the buttons a certain amount of times so they even out. It isn't possible. It's possible to do that with one or the other, but not. Oh, is that all that it is? You go up until you reach the correct X value, and then you just repeat the function of subtracting the amount and then adding the right amount to get it to equal 0. So, like, you get 6726. The difference to get this, so in this case, we have 26 and 67. She says second and fourth claw. Yeah. So these don't share any prime 67 is a prime number. So do we do this one? Yeah, 69 and 27. Okay. So X diff greatest common divisor. A's greatest common divisor equals 1 for I in range 100 if AX mod I equals 0 and BX mod I 0, then AGCD equals I. Okay, other than that, 0x is equal to, yeah, to get to zero out on the x, so then we have the 0 out on the y is equal to ax divided by a GCD. Or there should not be a, it should be xGCD. Webcomic, haha. And then bx divided by x GCD. I kind of just want to call it xGCD because it's just funny. So now we go all the way up to the very, very top. Oh, and now we do 0 diff, or 0 AY is equal to AY times 0 AX, and 0 BY is equal to BY times 0 A or BX. And then we have 0b diff is equal to 0, or 0y diff, sorry, is equal to 0ay minus 0by. Yeah, so we just count up all the way until we reach our threshold, where b press is equal to min of that. Cool. Then we wobble until we get okay. Now we need to find the smallest possible number that we can make to compare. Yeah, the smallest number we can make so that we can target the correct x value. Okay. For there shouldn't be for I in range. It should be just for j in range, just because we already have I defined. For j in range ax, or k in range bx, we want to find the lowest possible number that would find low x diff equals, for simplicity, I'm just going to do ax minus bx if abs of j times bx minus k times ax is less than low x diff and is greater than 0, then low x diff equals that number. Okay, so if bx minus px mod low x diff equals 0, then cont equals true. Means you can't actually do it. And what we do is we do b press minus equals oh, wait a second. bxpx divided by low x diff. Oh, so no, it should be not low x diff. Low x a, low x b equals 0 equals 0. K xb equals j. So oh, it's divided by low x diff times low b. And that's where we start. And then we now have a baseline where it matches up and this doesn't match up. Now we have to find the difference that we can get up to the very top. So a diff, I mean, this entire thing is kind of garbage now, right? Is equal to a press times ax. Well, because we paired on a B presses to get to the very max, right? But we don't know which one it is. Ah, shit. We don't know which one it is. We just assumed that we were doing Y. Which is fine. That's totally fine. So we're doing the number of B presses it takes to get for the B to reach Y. That's fine, as long as we're accounting for that. So now, A diff is A press times number of AX times AX. And then we have prize X minus BX, or B press minus, or times BX minus. So this is now the X diff. This is how far away we are right now. And then we have I don't know what is low X diff. Yeah, this is the lowest possible difference we can make with X. It should actually be low Y diff. Okay, so let's do BX to PX. We're going to fix it and say that we're skyrocketing BX to the very, very top. And then we're doing all this calculation. Cool. Able to weasel it into the correct position. And now, we are now saying, well, how far away is the Y difference? y difference We've done all of the b's necessary to reach x. Now we need to add y's until we get them equal. We know the difference between the two. I'm going with this all the wrong way. Oh, okay. Let's take a different approach. Okay, entirely different approach. I'm deleting everything I have here. Fuck this. I've done part one. I don't need to think about it anymore. A press equals, or if ax is greater than a y, then a max equals x. Else a max equals y. And we can do the exact same thing with b max, just so I have that set up. And I have an idea. If a max equals b max, then continue. It should be does not equal, yeah, so if it equals b max, continue. Otherwise, or wait, let me just make sure I understand what continue means. Okay, that's what I thought. Yeah, okay, I wanted to make sure. If a max equals b max, then continue, because it cannot possibly be that if they're both the higher values, that we can reach any of the values here. It just does not make sense unless they're all equal. Which we move this way. There we go. We've now covered the case where they're all equal. Because if they're not equal, if they are all equal and this is equal, it'll give the because yeah, it'll only work if they're all four of them are equal. If one of them's equal and the other one is not, it might actually work. It might go through the iteration even though it fails. else. Okay, we don't even need else. Cool. Now, we know for the fact that one of them is bigger than the other. For our simplicity, no, we can't do that for our simplicity. Because it doesn't matter which button you press. I was just saying we could just switch the buttons for the sake of convenience, but we actually can't. We can, and then come back and then fix it later, but I'd rather not. So, what we're start by doing is we're going to say B press is equal to the amount of times we need to press the B button to get the higher value. Yeah, so it's if B press equals, or B max equals X, then there we go. Cool. I don't know why I changed all of those. That should not have all been changed. I just wasn't paying attention. Okay. So now we have the number of A presses, the number of B presses we need. So we now have X diff is equal to PX minus AX times A press minus BX times B press. So we have a big number that reaches the very, very top, and a bunch of small ones at the very bottom. What we want to do now is remove the big one so that it fits in this gap. Ideally. Of one of the two. And then we wiggle until we get to the correct answer. Ah. So this is the amount we need to make up on X. So we've overshot. This is going to be the amount on Y that we've overshot. This number is going to be significantly less stupid. By, you know, a fraction relative to how far apart the numbers are from each other. I'm gonna call it y x off and y off actually. That's how off the targets are right now. So you've put in a bunch of the A's and gotten a bunch of X in a little bit, and a bunch of that in a little bit. So we have a bunch of the little bits on top. Actually, we shouldn't do the A press as much. We should do PX minus B press times BX divided by AX. Because this is the bigger one, we want to have fewer of these. So what we've done now is if we have B goes up to the very top of, let's just say it goes up to the top of X for simplicity. You have a little bit. Then A will fill up this gap with its big one, and then leave a little bit left over. And we have a little fraction of 2 left over to consider about. And now you have to consider how many removals do we have to do, and like how many trades are we going to do, right? How many swap overs? I'm having difficulty conceptualizing this right now. So, okay, let me just like demonstrate visually what I'm doing right now. Make sure that I can conceptualize it properly. We have to reach this threshold with 1 and this threshold with, so this, we're going to call this X and we're going to call this Y. So what we start by doing is pressing the B button, let's just assuming the B is larger for this case, B button until it reaches here. Or until it reaches the X. Technically, we want to go until it surpasses X slightly. And then we would have a bunch of Y's left over. And so this is B, and this is B. Then we do enough A to just barely get over Y. And we'd have a small sliver of this left over. What I think we can do at this point now is remove B's to get this down, right? And we can iterate like that. And we can keep iterating until we get there. So we just take this and chop it off. And because we're taking more, this is taking the large amount, we're taking a smaller amount of B's here and chopping that off. And then we iterate on that. I think that actually works. Okay. So while X off is greater than 100, or Y off is greater than 100. Actually, let's do 200 for the sake of make sure we have all of our bases covered. Um, so we see how much x off we are. This is the px minus of A presses we have. A B press we have. We have a bunch of B presses, but a bunch of A presses. So it's going to be a negative number. So B press plus equals X off divided by BX. And we've just taken that amount so that now this is correct, and we've taken a small amount of this off. And then we do so if B max equals X, then we do this. And then we do A press plus equals Y off divided by AX. In fact, I think we can just do this anyways. I don't even think we need this. Let me refresh this as well. So if there's a solution, this will get there in a pretty small amount of steps. Because it'll keep chunking and it'll just keep wiggling around by the difference in these numbers here. So the bigger the difference, so if it's like 99 to 1, they'll have a little tiny pile of B's here, big pile of B's here, with a big pile of A's here, with a big pile of A's up here. So we have to remove almost all of these B's in order to get this to work. And then we have a little tiny pile of A's, with a basically minuscule pile of B's here. And then things will just balance out pretty quickly. Okay. Else, we do the exact same thing, but we do Y off and BY. So X off and AX. Oh, there should be AY. Glad I checked that. So if X off plus Y off, while it's greater than the way this will adjust if they get into position relative lower than the difference between both of their numbers, which has to eventually happen. In fact, I think I could do minuses and it would work. Actually, I think the absolute of the minuses is more correct. In fact, I'm going to do that then, because it'll give me a tighter window. Okay. So now, once again, weird. Yes, I did mean double equals there, as a matter of fact. Oh, I need to define it earlier. Sweet. Okay. That went way too quickly. Wait, what? It actually just works? That fucking fast? No way. Okay, wait. Let's test real quickly and see how close we actually get to the correct answer. Oh, well, abs of X off. That would fix things. That's gonna take a lot longer, isn't it? It didn't. I mean, we're getting to closer numbers. Oh, I did this wrong. I wasn't scroll up all the way to the very top. Times 16 plus times 53. Wait, what? Oh. Yeah. Why is it getting kicked out? It says it nailed the X. Oh, that's redundant. That just doesn't work. Maybe I have to do it like this. And it just breaks it somehow. Okay. So it just didn't work. Function declaration just didn't fucking work. Okay. Actually, I should do... We should double this range. For weird reasons, but it's kind of important. Because it kind of fucks things up a little bit. I'm glad that I used the print statement to figure out why I was resolving so fucking quickly. Okay, let me change this to in range 1. Okay. So it says that the difference between the two are 37. I agree with that. Is that it got within 37. Okay. So let's test these numbers. Times 16 plus times 53. Whoa! Okay. And the target was 6788. And it's 37 away. Whoa! Okay. Holy shit. That's fast. I'm gonna put this to be within 100. Within 100, and it should end pretty quickly. Let's put in 10. Okay, that's fast. Let's put in lend buttons. Okay. Now we're fucking talking. So, now we have an X off difference that's less than 100. and a y-off difference is less than 100. I'm just going to do... Okay, let's run this again. Okay. So I'm actually going to do... This is fine. I can read it off here. That's how far the x-off is. That's the range. That's how far the y-off is, and that's our range. That's the... I guess AY minus BY doesn't actually fucking matter in here. I don't know why I have these numbers in here. So what we need to do is we need to find out how we can micro-adjust to these values. Actually, I'm not even going to do abs x off. Let me just do fucking x off. X off and y off. Cool. So we are 90 below on x, but 10 above on y. AX, AY, BX, BY. And we don't need to know the prize, because we've already calculated that. So, what I want to do now... So this is actually really promising. We've gotten incredibly close, and it's with what I believe to be basically the fewest amount necessary, right? Because when we start, right, if we can use this to identify which ones can we nail by some value, then we can figure out the minimums really easily from there. What's the lowest I can push this? Wow, that's really not very many. 100 loops would then just definitely be enough, right? That's so few. To go within 100? God, that was the correct solution. That's the correct pathing. So the great bucket problem, fight me. Okay. So if it reaches 250, okay, that's what I meant to do. Okay. So they all reach 250. None of them reach 0 naturally, but they're all within a little, much smaller window. I could probably do less than that, but I'm still doing 250 to really go overkill. So 4I or 4Q in range 250. I don't need to know loops anymore. So bam. Ah, geez, where's loops? Not there. I don't need loops. There we go. So I've gotten all my numbers into a very, very small window. They're all double digit away from the correct solution at worst. So now I get to figure out if it's possible to fix this issue. So once they've come all the way down here, we have now have a X off and a Y off. And we have is one always going to be below, one's always going to be above? Is that how that always works? Oh, we actually have some that are like on the fucking nose. Sweet. Okay. So what I want to do now is I want to edge. Well, Y is doesn't actually specify. I want to edge whichever one B is. So B max column. I want to edge that one to 0. So if B max equals X, then we're going to do the greatest common denominator, or greatest common divisor of the AX and BX. So X, greatest common divisor. This problem is really annoying. I really like this problem. It's a really, really cool problem. Equals 1. Range. Just range 100, I think, actually. If EX mod A, let's actually call this C for the sake of simplicity, so I don't get mixed up, equals 0, and, well, it should be the other way around. AX mod C equals 0, and BX mod C equals 0. Then X equals C. And now I want to look through. No, but I want to look through. I don't want to look through. Actually, coming in here. I want to see min diff equals 100. For C in range bx for C2, let's do C1 in range bx, in range ax, if C2 times bx, or actually, let's do C1 times ax minus C2 times bx is less than min diff, and this does not equal 0, then min diff equals this, and a diff equals 0, diff equals 0. Okay. So after all that, this doesn't matter whether it's... Oh, yes, this does matter if it's x. Okay. So if x off mod min diff equals 0 and min diff does not equal 100, then a press so plus equals x off divided by min diff. We take that many times a diff. And b press plus equals b diff. Else, we do the exact same thing, but we do it for y instead. And then we reevaluate once again, x off and y off. So there's no way to make that 37 up with these two numbers. Well, so they need to have a difference of 1, basically. Is there no modulus number where they separate by 1? So you get 5 pretty easily. Yeah, it actually should be possible. Oh, there should be absolute of that. Okay, no, we shouldn't do the absolute. We should just do and that's greater than 0. We should just say greater than 0 instead of not equal to 0. That fixes that entire problem. Oh, it should be plus, not minus. Okay, so this is now, if there are two numbers, then we can multiply each of these by and press that many times, and it creates a lower difference. Then we can find that lowest difference. Actually, we don't even need the lowest difference. We need one that's a multiple of our thing. If y off modulus this equals 0, then you know what we're looking for. I'll just do it like this. Um, um, 106 invalid syntax. Alright, I do need the close paren. 106 modulus by 0. If this does not equal 0 and that equals 0, then we continue. So in this case, B has a stronger X, which means we're looking at the X difference. So it says that you can't you can't do minus 37, but we know that we can. The absolute of that equals 0. Oh, that doesn't work. Oh, I'm gonna do absolute of that as well. This should work though. So now we can make minus 37 here. I know we can make minus 37. How do we evaluate if we can find... Because, like, okay, how did I find the difference, though? Because, so we have 53 minus 16 minus 16 minus 16. So we have 53 minus 16 minus 16 minus 16. We have 5. If we take 16 minus that, we get 16. Let me get that 3 times. We have 16, 10 times 16, minus 3 times 53. Because that's 0. So we actually do have to do negative numbers. Let's check something real quickly. Okay, I'll use that. That would work. We use arc, I definitely don't use that one yet. Oh, sorry, this should be AY. Fuck. I fucked that up. Balls, dude. That actually looks pretty decent. So if it's non-zero, it's non-zero, and I'm gonna do this just to get rid of. Oh, what's min-diff? Oh, shit. That's what I'm fucking missing, dude. I'm so dumb. Okay, we'll put this right around. Int is not callable? Oh, wait, why is there a... Intermodular by 0. Ah. Okay, still wrong, but okay. Okay. So this feels correct to me. Ah, why is that not working? Okay, if I take this entire block away, okay, then I copy this, paste it here. Literally no value change. So it's doing nothing for some reason. Why? What's A diff and B diff? C1 and C2. C1 you multiply by A. Yeah, that's what I fucked up on. A press is C1. This is C2. Way worse. But we're getting there. Okay. So I did have 21. That's correct. Y off. Oh, this is X off here. That's what I fucked up on. This is X. This is X. That's X. That's X. Okay. And X off. Okay. How big was this that I found before? It says 37. Okay. Okay. C1 min equals 100. C2 min 100. If C1 min plus C2 min is less than C, or is greater than C1 plus C2. Oh, actually, we want to look at the amount. 3 times C2. C2. Oh, no, it's the other way around. Then we do all this. Cool. And then we do C1 min equals C1. C2 min equals C2. There we go. This is what we're going to be doing. That should just work. I need to replace all of the X here with Y, which is going to be a bit of a chore, but I will survive. Whoops. Oh, gosh. There we go. So why is this ending up 0? So if Bmax is X, it's because that Bx is greater than By, which is the case. First question, Bx is greater than By. So we're definitely dealing with the top stuff here. So for an interesting examination, so it's definitely affecting this one, and it turns this one, okay. Turning that one 0 is what it's supposed to do. Okay. Ah, shit. It's almost 2 a.m. still going. I'm going to be finishing off very soon. This is annoying. I need to just do total count here. Yeah, let's just do total count here. Okay. And now we have a leftover. So if x off times y off equals 0, then break. Or then continue. We no longer do the rest. We skip this element of our loop because we know that this button is a failure. Otherwise, we do a similar calculation, but we now need to see if there is a way to have a 0x influence with a y influence. So we now do GCD equals 1 for Q in range. Oh gosh, this is another. If B max equals X, then for Q in range B Y, because we're now doing the opposite one. X is now fixed. If it's X, then X is fixed. For R in range AY. Oh no, it's not in that. It should be the range 100. Sure, whatever. If AY mod Q equals 0 and BY mod Q equals 0, then GCD equals Q. Then once we've eliminated the GCD, we should have numbers that are otherwise not multiples of each other. Oh, sorry, it shouldn't be AY. We actually do need to do X because we're trying to find. So now, else. Okay. So we now have the greater common denominator. What I need to do now is I need to take the so if b max equals x, then I need to do we need to see what y iteration we have. So we have to do y iter is equal to our b is equal right now. Sorry, the x is equal right now, which means we need to take. Okay, so we need to do extra b per equals bx divided by greatest common denominator. And that's extra b per is equal to ax divided by greatest common denominator. And then this is the lowest possible difference you could have. So our, okay, so now we do diff is equal, or yeah, y last diff is equal to ay times extra a per plus a by times extra b per. If y last diff, no, if y off mod y last diff equals 0, then a press plus equals y off divided by y last diff times extra a per, and then we do the same thing with b press. That should put them both to 0. Then we just do all of this. So x for y, x last diff What? X. Why does the guy coming down here is sucking 17? What? X off Y off A press B press A X A Y. Wait, do I have a is there a 1790? Did I accidentally change? Okay, 68. Okay, because there's okay. Some of them don't even make it this far. That's why. Okay, because this print kicks off. Okay, 68, 17. Cool. Next one is 1790. This does have a multiple of that. Oh. Why is this not a 0 aligned? This should be a 0 aligned. Oh, it should be not equal to 0, then continue. That's why this is so broken. This should be int, like this. And we should do one last of these. 0 zeros. Yes! Are these all 0 zeros? They're all 0 zeros. Oh my god, I got... Oh, wait. Did I forget a minus or a plus somewhere? Why is this one weird? 87. 8717. 2854 has rated coming out of meter 1. All the other ones work. Why does this one not work in particular? Oh wait, min diff was 100. Or min diff equals 100. That should have been disqualifying. Any of these other cases have 100? They shouldn't. That one does? What the fuck? Actually, I'm going to change min diff to 0 because that can't actually happen. $112. Actually, I should put in some weird number. 1, 2, 3, 4, 5, 6. There we go. It's a number that will never be obtained. These are all the possible outputs. And now, at the very, very end, we will finally go to total sum equals 0. We will do total sum plus equals x press, or a press, or 3 times a press plus b press. And this is going to be my final answer. If this is wrong, I'm going to come back into this problem because it's a really, really fun problem. It's not the right answer. My answer's too low. Okay. What? That's not what I expected. I thought they were going to say my answer's too high because I would need to optimize the A presses. But that's not the case. So I'm done. It's almost 2:30. I love this problem. I want to be able to continue doing it, but it's getting too late in the night. Thank you all for watching. Hope you guys enjoyed. I will see you all next time. I'm gonna keep doing this. This is great. This was amazing. This was a really, really solid problem. I had a lot of fun tackling it, and I think I can still get it. But it's gonna require a little bit more fuckery. We'll see.